Okay, this one's kind of a two-dimensional relative motion problem. I'm going to do it with the notation and drawing the triangle. You're going to have to draw the triangle, but if you skip the notation, I'm okay with that. All right, so we've got a toy boat, and it's moving at 5 meters per second west relative to the water. Using the notation v for velocity with the vector hat, it's the boat relative to the water. So b and w, and that's equal to 5 meters per second west. It says the water's moving at 2.5, water's moving at 2.5 meters per second south relative to the ground. So notation-wise, maybe think about it before I write it. V for velocity, and it's the water, so a W to the ground with a G, and that's 2.5 meters per second, happens to be pointing south. The question wants to know the resulting velocity of the boat relative to the ground. The notation-wise, to go from boat to ground, to do that, what we take is, let's write this out one more time, the boat to the ground is the velocity of the boat to the water plus the velocity of the water to the ground. Now we've got our equation. You could have maybe skipped all that. Now it's just a matter of adding them up. We take the boat to the water, which was the 5 pointing west. West is usually to the left of our page, so that's going to look like that. Where that ends, we draw the next vector. In this case, it's 2.5 pointing to the south. And then the vector rule for adding is you take your very starting point, connect it to your very ending point. That is your resultant. That is the answer. In this case, BG. Because it's on a funny angle, we're going to do a little bit of trig and get the angle. Always get the angle closest to the starting point, so we're going to find that angle up there. I'm going to call that X. All right, now it's turned into a math problem. We're kind of done the physics of it. We just have to do the math. The velocity that we're looking for, boat to ground, is Pythagorean theorem, 5 squared plus 2.5 squared. All of that, we've got a square root. You can double check with a calculator. When I do the math on that, I get, rounded off, 5.6 meters per second. Trig-wise, compared to the x, I know the opposite and the hypotenuse. So SOHCAHTOA, that's a tan relationship. The tan of the angle is the opposite, in this case 2.5 divided by 5. One more line. Figure out how to work your calculator. You have to use the inverse tan function of 2.5 over 5. 2.5 over 5 is just a half. So the inverse tan of a half, when I did it on my calculator, after rounding off, I get roughly 27 degrees. Okay, now the last step to put all this together, we now know that the velocity of the boat relative to the ground is 5.6 meters per second, and it's on this 27-degree angle. If we go back and look at the original triangle, the 27, so it's up here, is how far away from straight west we were pointing. So in the square brackets, I'm going to say straight west, and then 27 degrees we bent towards the south. So our final answer is 5.6 meters per second west, 27 degrees south.